Hello there, this is exercise 3E.1. We're going to look at transformations now in 3 dimensions rather than 2. And you can see in the picture we've got this cup being rotated about a some line straight through the middle of the cups. And I suppose what this suggests is there are certain transformations that we need to know. And the main ones are going to be rotations, as indicated by the picture, but also reflections. There's not so much variety on this, and probably because it just gets a bit more complicated. So these are the reflections initially. You'll notice now these are meant to be axes. So look at these. Now one slight issue we have is you can draw the x, y and z axes in more ways than you probably have thought about in the past. So on this picture x is going this way, but sometimes it goes straight across. And sometimes the Y goes up, and sometimes the Z goes in and out. So just be aware that they can go in any direction. We talk about the XY plane, the ZY plane, and stuff like this. Now notice this is the YZ plane. It's this plane that you get, and by a plane you just mean like this flat surface. That is you get when where the y-axis and the z-axis kind of matter, but you'll notice it doesn't come in and out at all. So we define that to be x is 0. So when x doesn't feature, we call that the yz plane. And we might reflect something in that plane. There's something on this side, it reflects over to there, and so on. So you're going to have to get your head around this. So you'll notice when x is 0, we call that the yz plane. When y is 0, we call that the xz plane. Then z is 0. And you'll notice it's the letter that is missing. And interestingly, when x is 0, it's the first number in the matrix that does this, which is -1. When the y is 0, it's there and there. And I have to point out, these are not in the formula book, so you are going to have to learn these, or at least learn how to find them if you've forgotten. So I've shown you tricks of how to do that in normal maths, in further maths with 2 dimensions. So let's just bear those in mind. This says a transformation R represents a reflection in the plane x is 0. Show that the 3×3 matrix for R is this. Now notice that's what I told you it was. This is x equals 0. So it's in the yz plane, x is 0. I've told you this answer, but this is a prove. This is a show that this is true. And so I suppose the way to do this is in the same way that we've done with normal matrices. What you need to do is you need to say to yourself, my matrix is going to be what happens to first of all the 1, 0, 0. So if you find 1, 0, 0 on this picture and you say to yourself, where will that go? And 1 is in the x direction, so that's there almost. 0 up, so 0 in the y, 0 in the z. So that point there, I think, will go over there when I reflect it over there. So because of that, you see, that is now, if that's 1 in the positive direction, and this is a bit weird, you don't often see negatives going in that direction, but there it is, that's 1 that way, -1. And of course it's still 0 in that direction, it's still 0 up. So my matrix is -1, 0, 0. And I suppose the big question is how do you show this properly, but we'll worry about that, justifying it later on perhaps in an exam setting. What happens to, well, you now look at the point 0, 1, 0. What happens to 0, 1, 0? Now 0, 1, 0 means it's 0 in the x and it's 1 in the y and it's 0 up, so I think it's that point. And what happens to that point? Well, actually it doesn't move at all. It's being reflected in this line and therefore it just sits where it is. So I think that point goes to 0, 1, 0. That might be the way to do it, actually, to show this as, you know, what happens to each coordinate. So that point goes to there, so therefore I can write 0, 1, 0. And the last one is what happens to the point 0, 0, 1. And 0, 0, 1 goes to, well, 0, let's find it first. 0 that way, 0 that way, it's that point there. But that, I think, is also in this plane. When I reflect it in this line, I think it stays at 0.01. So it definitely is. That's the way perhaps we will learn to remember how to do it. That's my matrix. Probably fair to say, though, if that came up in the exam, we'd want a slightly better method. But I think that's good enough for now. Anyway, so that's it. So I've just said what the answer is. This is the book's answers. Actually, they've done exactly the same as I've done. They've just shown each coordinate. I was wondering if we could perhaps use inverse matrices there, but they didn't do that either. The book just said this is what to do. Secondly, then, we have rotations. And the rotations, the good news is these are in the form of the book, but not quite in this form. But you can go through these and you can show that these are true. And perhaps we'll do that in a bit. In the form of the book, you get these. And this is the exact wording. I'll just copy the text in to this PowerPoint. It says rotations through theta about the coordinate axes. The direction of positive rotation is taken to be anti-clockwise. But now, of course, anti-clockwise is a bit less obvious because it's in 3 dimensions. When looking towards the origin from the positive side of the axis of rotation, that's a bit of gobbledygook, really. It's quite hard to define. But notice the 1, if you're rotating about the x-axis, so let's just draw. I'm going to deliberately draw my axes the other way this time. I'm going to draw my x this way, my y this way, and this time my z is going to go in and out. Now you've got that choice as to which way you draw them, so that's what I've drawn. So there's my x, y and z. And if I rotate an object about this axis, you can imagine it going, well, they've said it goes anti-clockwise. I would have thought it probably goes like that direction if that's the case. You can see I could quite easily then rotate it about the x-axis. So if you can imagine it's quite hard to draw. I suppose that's the only problem. We had a cup before, didn't we? So let's have a cup drawn there. Now that's my cup on this. It's a 3D cup. You can tell it's a beautiful cup. So if I was to rotate it, I reckon 180 degrees. I reckon it would still look like that. This is assuming, of course, I'm rotating it about this x-axis. And I reckon it would look like that. It'd be an upside down version as I went around 180 degrees. Now, when you're doing that, that's obviously cos of 180. Just look at that, cos of 180. So cos of 180, that allows me to say, well, what is cos of 180? That's actually -1 if you do that. The cos graph looks like this. That 180 is down here. Now, these were 90-degree rotations, so, obviously it's slightly different. This is about the x-axis. But if I did a 90-degree turn instead, cos of 90, well, that is there. That is 0. So you can see that is 0. So these formulas I've given you here are perfectly true. But in actual fact, the exam booklet gives us these, and they're probably the easiest ones to use. So let's use this idea of rotations. We're going to, it says T represents a 90-degree rotation. So I suppose straight away we should be thinking 90-degree rotation. We need to use this. These are 90-degree rotations as well. That's interesting. We could just jump straight to that. So that's what at least what the answer should be. But it says about the z-axis. So probably the best way of doing that is to say to yourself, imagine I had those 3 points that we saw again at the start. So again, I'll write them as vectors this time. I could have written them as coordinates again. Where does 1, 0, 0 end up? So 1, 0, 0 is, it's along this axis. It doesn't go any up. It doesn't go any across. It's just 1 in the x-axis. And this is saying it represents a 90-degree rotation about the z-axis. Now this is the z-axis, so I'm just going to draw that going down. So I want you to imagine everything rotating about that line, 90 degrees. And I reckon if I rotate that about there, it'll go to there. So there is, well, I reckon that's the coordinate 0, 1, 0. Notice it's no distance in the x. It doesn't come out at all this way. It goes 1 that way, but it doesn't go any up. So reading those coordinates is quite tricky anyway. So my next point is actually that point. You do 0, 1, 0. Where does that go? If I rotate that point, Oh, I think I'm going to need to draw this x-axis going further back, because I think if I rotate it, again, remember we're rotating around this line, so it just goes around here. And I'm rotating in that direction. I suppose, is that the right direction is another story. Anyway, I reckon it ends up there, and I reckon that is now -1 in the x-axis, 0 in the y, and 0 up, which is of course the numbers I've got here. And the last one is 0, 0, 1. Where does that go to? Well, 0, 0, 1 is there. There's that point. If I rotate it about the z-axis, well, it is on the z-axis, so it's not going to move. It's going to stay as 0, 0, 1. And then if you put those all together, my t must be, because they call it a t transformation, it will end up being there, 0, 1, 0, minus 1, 0, 0, and the last one, 0, 0, 1, which is really no more than confirming what they told us in the question. But I suppose it's a nice way of being able to find it, even if they don't tell us. Now, summary then, the rotations are given to you in the formula book, that's great. Reflections are not, so they are the general ones, and the reflections as well. So I've got an exam question for you, and I've not done it before, so we'll see how it goes. A reflection, A is a reflection, write down the value of the determinant of A, and it's 1 mark. Now notice 1 mark really says you can use a calculator, but unfortunately they've said A squared in it, so I suppose I can't. But anyway, determinant of A is 1 times by, oh I see, this is actually quite easy. It's 1 times by A squared 0, 0, 1. But then we'd go minus 0 times by something, plus 0 times by something else. We use these three numbers, and because those are noughts, actually, this is dead easy to do. This becomes A squared. I think the answer is just A squared. I do 1 times that, which is A squared minus nothing, and that's A squared. Okay, that's easy enough. Hence find the possible values of A. Well, I suppose if this is true, one thing I know about a reflection is we know that the determinant of reflections, we saw this in our work on 2D matrices, the determinant is always -1. So I suppose we can say A squared is -1. Now this is actually a bit naughty for us anyway at this stage, because we aren't able to write answers for this. You can later on, and I'm going to write the answers now. I'm going to write plus or minus I. Now these are something called complex numbers, and we don't come across these till later. You can see this in the exam question, which mixes the topics up. They're complex numbers, and we don't need to worry about them too much at the moment. Part 3 says R is the position vector of a point R. And again, this is something which at the moment we're not going to be able to do. So let's just for the moment, again, the other one I could do, we could make that up. But this one we definitely haven't done vectors yet, so I'm going to ignore that. B represents a rotation. Right, now if it's a rotation, we should know that the determinant should be 1, I think. And if that's true, hence find the possible values of B, well, let's just do this determinant of this. I'm going to do some work in and then pause the video. So I've written out the determinant calculation. Now if I do that, I get 0.6 times by 0.6 minus B times by minus B, and this last bit is just 0. So what do I get? I get 0.36 plus B squared, and I reckon that's equal to 1. And B squared therefore is minus 0.64. And I reckon therefore B, if I square root that, I get the square root of 0.64. And I reckon that's plus or minus 0.8. It'd be easy to miss out the plus or minus, but and it did want plus or minus. And it did want plus or minus y. Now this bit we haven't done yet, so don't worry about that answer, but everything else we've done. We'll in lesson look more at this. Don't worry too much about the determinant stuff. I think that will come a bit more later. In our second video on this, we look at determinant amongst other things, and hopefully that will make a bit more sense. Everything else should be okay, so see if you can practice that from the textbook.